Welcome to this demo of PlanPilot, an interactive tool for navigating large plan spaces in AI planning tasks. We will demonstrate our approach using the classic blocks world domain. PlanPilot is based on answerset programming and coding of planning, which is parameterized by a horizon, a bound on the maximal plan length. We begin on the start page, where we input two PDDL files, the domain and the problem file. PlanPilot then computes the optimal plan length using fast downward. Next, let's move to the PlanPilot page. The domain, problem, and calculated horizon are loaded automatically, and the user can adjust the horizon manually if desired. Several options help to control the solution space and tailor the navigation to individual needs. Encoding. The exact encoding enforces plans of exactly the given length, whereas bounded allows shorter plans within the limit. Time step. Our default encoding uses concrete time steps, which means that every step in the plan is assigned a specific ground action. Abstract time steps allows action occurrence at any point, abstracting away the specific time step. Once configured, we can compute the available facets, which is the main operation to explore the plan space. A facet is a choice point in a plan where multiple actions are possible. Depending on that choice, the remaining choices are reduced. Facets allow us to explore the plan space systematically. PlanPilot lists all choice points to the user, who can activate the facets to restrict the set of plans. Activating an inclusive facet enforces the corresponding action in the time step. Activating an excluding facet forbids the action in that step. Let's say we activate this facet. Then this restricts the remaining choices, reducing the number of facets. We can always compute the number of remaining facets to choose from, which takes into account the currently activated facets. In our example, there are 68 facets after the first activation. In the same way as we can count and enumerate the facets, we can also count and enumerate all or just a number of plans that comply with the activated facets. Here there are 10 plans remaining that include action pickup E in step 11. Counting and enumerating plans is computationally more expensive than the facet operations, so working with facets enables a smoother plan space exploration. When navigating with the facets, we can enable some statistics that help to decide on the implications of activating a facet. This allows us to select facets that restrict the plan space very heavily, for example, enabling this action, which reduces the number of facets by 76%. If we prefer to keep as much freedom as possible, we could activate this facet, which only reduces the number of remaining facets by 41%. Similar statistics can be found for the reduction in the number of plans. At every point in the navigation, certain actions can be implied by the choice that have been done up to that point. These are a form of landmark actions, action occurrences that are implied by the activated facets. Let's look at a concrete example. We have a blocks world task where initially all blocks are on the table and the goal is to construct two towers, each with 4 blocks. Without restriction, many solutions are possible. There are 20 plans. But when we activate the facet that A should be stacked on B at time step 6, only one solution remains. Enforcing this action at step 6 is extremely restrictive. This demonstrates how just one facet can dramatically reduce the solution space, which enables a fine-grained step-by-step exploration of the set of possible plans. For blocks world, we can visualize the solution graphically. Activating one facet caused a single remaining solution, where the first tower is constructed fully before the second one. In our second use case, we showcase how facet navigation can be used to identify bad action choices. Here we activate that A should be stacked on B at time step 1. We can see now that there is no facet left to select, so there is just one solution left. In that plan, we can see that in the subsequent step, step 2, the first action is undone, indicating that activating the first facet was a mistake. Thereby, PlanPilot can help to detect and understand such errors interactively. Similarly, it can aid in model debugging if we navigate a set of actions that we believe should occur in a plan, but that turn out not to be possible to execute. PlanPilot is a very versatile tool that enables interactive navigation of the solution space of planning tasks by facet reasoning. Thank you for watching this demo.